Hey there, geometry world. After teaching this for a few years, I realized that section 10.3 and 10.4 are truly intertwined. And what they have to do with are what are called composite figures, more than one figure combined, finding area and perimeter in the coordinate plane, which is just got a little hitch to it, and then estimating area, which is probably one of the most important things of all. These subjects are what you're going to be doing when you design a house, when you lay out your property, when you try to estimate how big something is, or the volume or area of something. So these are really important life skills. I want you to see examples here, and that way when we're in class we can practice it together. So this, by the way, is a composite shape, right? It's made up of a triangle, a trapezoid, a rectangle, and two 3/4 circles. So the idea is we could find the area of this if we simply add together the area of each part. Well, let's just do a little sample problem, and I'll show you how this plays out. So here, if I want to find the area of the entire thing, I would say, okay, well, I've really got three figures I'm trying to deal with. I'm going to take the area of the total is equal to the area of the half circle, I guess that's called a hemisphere, plus the area of the rectangle, which is really a parallelogram, plus the area of the triangle. And so each one of these things, it really isn't so bad if you just break it down into parts. So let's figure out each part. Let's start with this side here. I know right off the bat, if the total length from here to here is 6, well, these congruent marks mean that each one of these are equal. That means 6 divided by 2, each one of those have to be 3. Sweet, life is good. Now, to find the area of this rectangle, which is a parallelogram, the area of this is base times height, 10 times 3, and that's 30. Okay? Now, if I said, hey, find the area of this triangle, well, you'd say, oh, Mr. Rising, that's 1/2 base times height. 1/2 base times height. And again, 30 divided by 2 is 15. Well, sweet. So far, so good. I'm 2/3 of the way here. Now, the last figure is this thing. And depending on my board, it looks like a hemisphere. Here, it looks like part of an egg. But it's supposed to be a half a circle. Anyway, so the full length across a circle is called a diameter. So halfway across the circle is called a radius. So really, from here to here is 5. It's a radius. And then how do you find the area of a circle? Area of a circle, or I should even say area of a circle is pi r squared. And then what I'm going to have to do is, because I want 1/2 of that, is divide it by 2. All right? Well, my radius is 5, so I got 5 squared pi divided by 2. And I'm actually going to use my calculator here. I'm going to put this all together as a nice answer, and I get 5 squared is 25. 25 times pi, and I'm using the pi key on my calculator. I'm not using, there you go, 25 times pi. And I divide it by 2, and I get 39.27. 39.27. Okay, so now I've got my three parts. This is 39.27. Now I simply need to add those three parts together, and I get 39.27 plus 30 plus 15, and the total area is 84.27. Units squared. So this is a classic composite problem. Now, the next problem I want to look at is, hey, what if it said, find the area of the shaded region in terms of pi? Leave answers in, find the shaded region in terms of r, leave your answer in terms of pi. So really what I'm doing here is finding the area of the circle. So the area of the shaded, equals area of the circle minus the area of the square. All right, well, the area of a circle, and again, I don't know what the radius is, but the area of the circle is pi r squared. And the circle's interesting because this length right here is a radius. So I don't have the side length. What I have is the apothem. Okay, so let's think about it this way. A square is also a rhombus, right? So really, the area of this square is 1/2 diagonal 1 times diagonal 2. And I know those two diagonals are the same, right? Okay, so if this is r and this is r, then the length, the full length across it is 2r. And the same thing here. The length from here to here is 2r. Okay, so if I want to rewrite this, I've got pi r squared equals 1/2 2r times 2r. All right, now let's simplify all this. 2r times 2r is 4r squared. 4r squared divided by 2 is, there you go, is 2r squared. And then I get pi r squared. So pi r squared minus 2r squared. All right. Now, can you combine those? Yeah, you can actually factor out an r squared. So this answer to me is okay. I can live with that. Or if you want to factor out an r squared, then you end up with pi minus 2. So this is the formula, regardless of the size of the radius of that circle, to figure out what the shaded portion, the area that shaded portion of the circle is. Now, the next areas I want to talk about, or things I want to get into, are when you get into a coordinate plane. So if you can use a straight up formula, use a formula like the area of a triangle, right? No problem. I'm going to show you a method for subtracting one figure that has sides that are hard to work with, and then we're going to get into estimating area of irregular figures. So take a look at this triangle here. Find the perimeter and area of this triangle. Well, I'm going to start with the area because it's really straightforward. Hey, if I just come in and I just drop a quick altitude, right? Oh, I have my base and my height because there's a horizontal, and a vertical line. So simply put, when I do that, this distance here, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 units. The height, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 8 by 8. Okay, 8 units. The area of this triangle, 1/2, 8 by 8. 8 times 8 is 64. The area is 32 units squared. Now, the perimeter is the hard one. And the reason the perimeter is the hard one is you need to come up with the side lengths of this side here and this side here. And you'll notice that it's like, oh man, how do you find the side length of that? Well, actually what you have to do is make right triangles and figure out the length of these diagonals. And so what I'm talking about is the following. If I come in here real quick and I say, hey, I've got like that and like that, I can figure out this diagonal. And if I go here to here, I can figure out this diagonal. So now I know this length is 8, right? This length is 6, this is 2, this is 8. So now in order to find this side right here, let me use a different color like yellow, right? This yellow line, oh wait, this is a right triangle. Oh, wait a minute. Square root of 2 squared plus 8 squared. 2 squared is 4, 8 squared is 64, square root is 68. Okay, this one over here, again, I have another right triangle. So I've got the square root of, again, c squared equals a squared plus b squared. So I've got 8 squared plus 6 squared. 8 squared is 64. 6 squared is 36. Add them together, you get 100. Square root of 100 is 10. So now I know this side is 10. This side here is some awful number, the square root of 68. And this length is 8. The perimeter is 8 plus 10 plus the square root of 68. And again, if I want to evaluate that on a calculator, I can do that. I can just plug in the square root of 68 on my calculator. I get 8.24. If it says leave it as an exact answer, that means you actually have to do it as an exact answer. And I'm going to add 18 to that, and I get 26.25. At this point in the lecture, I'm going to stop the video. We're at 10 minutes in. If you want to start taking a look at problems in the book, you can, or take a look at the next part of this lecture, and I'll show you the other set of problems that go with it.